it's me, Mrs. Pound. I'm back, and we're moving right along in our chapter on the nature of matter and purposeful designs, physical science. Today we're going to talk about liquids in section 1.2.4. So our objectives today are to identify properties unique to liquids and compare the viscosity of liquids. Oh, what's that word? Viscosity. So a liquid is the state in which matter has definite volume but not definite shape, unlike a solid that has definite shape and definite volume. When we're talking about liquids, we're going to be also talking about surface tension, the greater force acting on particles at the surface of a liquid. If we take a look at these drops here, these drops of dew on these leaves, we can see that they're nice and round. And what holds those drops of dew together is a force between the particles of the liquid holding them together. So that's what holds that together. It's also what holds bubbles together is surface tension. So I want you to try this on page 31. And if you don't have your book handy, what you'd have to do is you put a needle on a piece of like tissue paper or on a tissue, and you float it on top of the water using the surface tension. Then you add a drop of dish soap and see what happens. And what I want you to answer is, did the soap increase or decrease the surface tension of the water? I'm not going to answer this for you. We will talk about it tomorrow in class. So let's talk about the molecular structure of a liquid and how it relates to its properties. So 3 things, just like for a solid. Number 1, liquids have more energy in their molecules than solids, allowing them to overcome some of the effects of cohesion. So cohesion really held those molecules in place. Remember, they're still moving because they're vibrating back and forth, but now I have a jar of marbles, just like I had the marbles in the solids. Now they're able to move and pass over one another. They're not fixed in their position. They're still relatively closely packed, but they're moving over each other, just like if you were to pour marbles out of a jar. So the second thing about them is they are able to move and roll over each other. They're able to flow. That's why water flows. So I have some nice flowing water in the background there. And the third thing is liquids take the shape of their container. So no matter what bottle we have filled with water there, it would take any of those shapes. Now, another property of liquids is adhesion. They not only stick together for surface tension, they also adhere to other things. This is the attractive force between unlike substances that hold them together. So the water drops in the background here, they not only have surface tension that's holding them in the drops, they're also adhering to the stem. So they have attraction between the molecules themselves, and they have attraction to molecules of other substances as well. Another property of liquids that we talk about is viscosity, a liquid's resistance to flow. And here in the background we have some honey. And if you've ever tried to pour honey, it takes a while. It's not like water. Honey is more, we say, viscous than water. It has a resistance to flow. Something like molasses, okay, also has a resistance to flow. It takes it a while. Corn syrup, okay, if you've ever worked with corn syrup, it can be tricky because it also has high viscosity, a high resistance to flow. So I've given you a few examples, but what I want you to do is look in your refrigerator, or if you're watching this video at school, think of what's in your refrigerator. And I want you to think of some liquids in your refrigerator that have a higher viscosity than water, so a higher resistance to flow than water. Pause the video and think of those and write a few down. So I've thought about some things in my refrigerator, and some things in my refrigerator are ketchup, syrup, mustard, ranch dressing, hot sauce, jelly, and molasses. Those were some things that I had. You might have other things. You can add my things to yours if you would like, or you don't have to. That's okay. Now, another thing that we talk about the viscosity of are motor oils. Motor oils are a common lubricant. Do lubricants have high or low viscosity? Think of motor oil compared to water. Think of other things that we might use as lubricants, other things that we use to make things slide together with less friction. Okay? It has a high viscosity. Motor oil is thicker, we would say, than water. It's more viscous, so it has a high resistance to flow. Also, I'm thinking something like lotion makes our hands really slippery. That is much more viscous than water as well. So our objectives today were to identify properties unique to liquids and to compare the viscosity of liquids. So now we know what viscosity is. Now don't forget your 5 questions.